we will see that Joule's mechanical equivalent of heat. Okay, the statement of this Joule's law is mechanical energy can be converted into internal energy and vice versa. Vice versa means you can convert that internal energy into mechanical energy also. Okay, so how it is possible? Okay, so that Joule's made an experiment to prove this conversation. Okay, before Joule, okay, the people start think about actually it is not in the form of a fluid. Okay, it's called a caloric fluid. So when hot object, it can convert that fluid wise to the lower objects, lower temperature objects. Okay, so people start believe that it is not in a energy in the form of that fluid. Okay, later the Joule made his experiment and proved that heat is not a fluid form. Actually, it is the meaning of energy transfer. Okay, so here we have to see the concept of the thing. Mechanical energy is converted into internal energy of the material. Okay, then we see the help of a diagram. This is a diagram of Joule's experiment. Here this is called like a calorimeter, which means is a non-current of heat material. Which means it is not converted from inside to outside. Okay, it's called insulated container of water. Take a jar and fill it with the big beaker filled with the water. Okay, then it is connected with the one thermometer here to measure the temperature of the water. Okay, then it is connected with the feather like this. See, feather it has a bottom of like a stirrer. Okay, this help to rotate the water. Okay, then here the two masters are there. Okay, two masters are attached with the rope. Okay, with the pedal wheel as shown in figure here. Okay, when these masses, see, so mass will be adding the masses means what will happen, it will be moving downwards with the help of a gravitational force. Okay, so we write that the mass of the this thing is m, then g is what, gravity field is adding downwards, so that it is attached with the two pulleys with the pedal. Whenever the masses of the body pulling downwards means it will be rotate. Okay, the pedal will be rotate. So the rotation is attached with this bottom also. So water will be what rotate. Okay, so due to the turning of this wheel inside the water, which makes a frictional force. Okay, frictional force means, see, these are the metal or attached while rotating with the water. This makes a frictional force. Okay, in between the water and the pedal. Okay, pedal wheel. So this friction force is causes the temperature rise in the water. Okay, so that is measured with the help of a thermometer. Okay, here the gravitational potential energy takes place here. That is converted into what? Internal energy of the water. When the weight is acting downwards, okay, so that the which rotates the pedal wheel, so that the friction force takes place inside the water, it is converting the heat energy, that is called internal energy. Okay, so the temperature of water rises. Okay, to do the work done on the masses, so by the masses. Whenever the mass is increases, the rotation also increases. Clear? So Joules was able to show that the mechanical work has the same effect of the giving heat energy. Okay, the rotation of water producing a more heat. Okay, so this action is called what? Mechanical action. You can convert it into the internal energy, that is called heat energy. Okay, then he found that suppose we take that 1 gram of the water means by the increase by the temperature of 1 degree Celsius, it's producing a heat energy. Okay, that is called 4.186. Okay, the amount of heat energy will be it is equal to 4.186 joule. Okay, this heat energy you can say is called 1 calorie. So 1 calorie is equal to 4.186 joule. Okay, next we will see that first law of thermodynamics. Okay, so first law is statement about that conservation of energy only. Okay, this is the law of conservation of energy. Conservation means is constant, remains same. Okay. So what are the energy transferred in the system to surroundings or vice versa? It should be constant. Okay. First, you know that what is the energy means. You know the kinetic energy and potential energy are there. Okay. Here the first law is deals with that energy with the heat. Okay. So I will write that equation first. Del U. Del U. You know U is called internal energy. Delta meaning it's a changes. Okay. Changes in the internal energy is equal to the amount of heat energy is to the applied to the system with the difference of this work done. Okay. So del U is equal to Q minus W. Okay. That is the difference in that the amount of heat energy is supplied to the system. See, if this is a system, this is surroundings. Okay. So if we have to apply the heat energy to the system, heat energy, say Q, okay, to system, it should be some work done is there. Okay. So there is a work done is take place here. Work done maybe increases or decreases. Okay. So the work done by the system on the surroundings, that is called internal energy or change in internal energy. Okay. Initially system has some internal energy before it is given or supplied. Okay. If the changes in the internal energy of the system is based upon that the amount of heat energy is given to the system and it makes that work done, that is on the surroundings. Clear? So the internal energy of the system okay can be changed either by heating or by work done. Okay. By heating or by work. Okay. Next we can understand easily. So what's happening to the first law of the thermodynamics to the system and surroundings. If heat flows into the system, what will happen? The internal energy of the object will be increases, no? Yeah, it increases. Suppose heat flows out of the system, the energy will be decreases. Okay, so both are is on the system only. If the work is done on the system, so work is done means what will happen? It will be increasing the energy. Okay. Work is done by the system means it loses energy, so energy will be decreases. Clear? Work is done on, so energy is gained. Same meaning of heat flows. Work is done by the system is same as heat flows out. Clear? You can understand both that heat and work done on the system. About is the internal energy. Okay. Next. So based on the above table, okay, here the sign convention is introduced to use the first law of the thermodynamics. Okay. See, if the system gains heat, the amount of energy become positive. We are applying. System loses heat, Q is negative. Okay. What is Q? The heat energy is supplied to the system. Okay. Work done on the system, W is positive. Work done by the system is W is negative here. Here W is positive. Clear? Gains heat, Q is positive. System loses heat, Q is negative. Work done on the system means W, work done is negative. Work done by the system, okay, so W is positive. So you can understand the other example also in the diagram. Take that cylinder, okay, cylinder is made up of the piston is attached here. Consider gas, okay. So this is gas, this is a piston, this is a cylinder, okay. So initially, okay, so we have to think about that what is the internal energy of the gas. Now heat is supplied. What will happen? It gains that internal energy. Okay. So the Q is what? Heat is also more than 0. So work done is positive because work done by the system is there. Second thing, we have the piston is moved downwards. Okay. So down means same is heating also applied here, so that is energy will be increases. So amount of Q heat will be increases, that is greater than 0. But we have work done is done by the system means it will be less than 0, it's negative. Clear? Third, this is the meaning of there is no heat energy supplied to here, so that Q will be less than 0. Here there is no heat supplied here, so that Q, the system is not gain the heat, so Q is less than 0. But here the work done is okay on the system, so W is what, less than 0. Now there is no work done here, okay, which means work done by the system is positive. There is no heat supplied, so Q is what, less than 0. If heat is supplied means Q is positive. There is no work done on the system at 1 and 4, so W will be positive. If we are to work done by the system means W is negative, simple. Okay, so we are thinking about that Q and W. Q is what, heat, W is work done. Okay.